Ever considered yourself a time traveler just by stepping on a plane? Sounds absurd? Well, it's not as far-fetched as it seems. Welcome to the fascinating world of time dilation, where time can either be your snail-paced companion or your lightning-fast adversary. You see, time is not as constant as we perceive it to be. It bends and stretches, much like a rubber band, influenced by speed and gravity. This is not some abstract concept confined to the realms of sci-fi. It's a fundamental principle of our universe, and it's happening right now, even as we speak. Think about it. Hasn't there been instances when an entire day seemed to whiz past because you were engrossed in something you love? Or conversely, a single minute felt like an eternity when you were doing something you detest? That's time dilation in a nutshell, albeit on a very human scale. So, if time can be so fickle here on Earth, what about out there in the vastness of space? Time and space isn't as straightforward as on Earth. Let's dive into the concept of space-time, the four-dimensional fabric of our universe. If you've ever seen a trampoline with a heavy ball in the middle, you've got a basic idea of how this works. The trampoline fabric represents space-time, and the ball illustrates a mass distorting that fabric. Now, imagine rolling a smaller ball across the trampoline. Instead of going straight, it curves around the heavier ball. Similarly, mass and energy in the universe distort the fabric of space-time, causing other objects to move along curved paths. This is the essence of gravity according to Einstein's general theory of relativity. But what has this got to do with time? Well, this is where things get a little mind-boggling. Time, as it turns out, is also affected by the warping of space-time. This leads to a fascinating and rather strange phenomenon known as time dilation. Time dilation is the idea that time passes at different rates in different gravitational fields. The stronger the gravitational field, the slower time passes. So if you're standing on a massive planet, your wristwatch will tick slower than an identical watch floating freely in space. This isn't just a theoretical concept, mind you. It's been tested and confirmed with ultra-precise atomic clocks. It's important to note that from your perspective, your watch is not slow. Time appears to be passing normally. It's only when comparing clocks from different gravitational fields that the difference becomes apparent. This is the heart of time dilation and the broader concept of relativity. So, in the grand scheme of things, time is not a constant, unchanging entity. It ebbs and flows with the curvature of space-time, shaped by the mass and energy within the universe. So, the next time you're late for an appointment, just blame it on the curvature of space-time. Imagine celebrating your birthday every 88 days. Now that we've gotten your attention, let's dive into the concept of otherworldly clocks. You see, time doesn't tick the same way everywhere in our vast universe. It varies significantly based on a planet's rotation and orbit around the sun. Take Mercury, for instance, the smallest and innermost planet in our solar system. This tiny, sun-scorched world has a year that lasts a mere 88 Earth days. That's right, 88. This is because it takes Mercury just about that long to complete one full orbit around the sun. But that's not all. Mercury's day-night cycle, or the time it takes to rotate once on its axis, is incredibly slow compared to ours. In fact, one Mercurian day lasts approximately 59 Earth days. So if you were to live on Mercury, your day would consist of long periods of scorching heat followed by extended spans of freezing cold. Now let's take a leap to the gas giant Jupiter, the largest planet in our solar system. A year on Jupiter, meaning its full orbit around the sun, lasts about 12 Earth years, but Jupiter spins on its axis very quickly. A day there lasts only around 9 hours and 55 minutes. Imagine having to fit in all your daily activities in less than half the time we usually get here on Earth. And if you think that's wild, hold on to your space helmets. A day on Venus, our closest planetary neighbor, lasts longer than its year. It takes Venus about 243 Earth days to rotate on its axis, but only about 225 Earth days to orbit the sun. These examples illustrate just how different the concept of time can be when we step outside our earthly bounds. So next time you feel like your day is dragging on, just remember, you could be on Mercury, waiting for the sun to set for 59 Earth days. Living on Mercury, you'd have a lot of birthday candles to blow out. Would you meet your future self, if you could? Imagine for a moment stepping into a machine, dialing a date years from now, and emerging to see your future self. Sounds exciting, right? But this is where the concept of time travel starts to unravel, and paradoxes come into play. The most famous of these is the grandfather paradox. Let's say you travel back in time and accidentally prevent your grandparents from meeting. This would mean your parents, and by extension you, could never have been born. So, who then traveled back in time in the first place? It's a real mind-bender, isn't it? Another paradox is the bootstrap paradox, a concept that suggests that information or objects can exist without any origin. For instance, imagine you received a book from your future self. You read it, treasured it, and then when you travel to the future, you hand the same book to your younger self. So where did the book come from? Who wrote it originally? It seems to exist in a perpetual loop, with no clear point of creation. Now let's take a moment to consider the predestination paradox, which posits that time travelers are part of history and their actions in the past were always meant to happen. This means if you went back in time to change something, you would actually be fulfilling your role in creating the history you know. While these paradoxes are fascinating to ponder, they also highlight the complexities and potential pitfalls of time travel. If we could meet our future selves, would we also be risking the unraveling of the time-space continuum? Could our actions in the past or future have unforeseen and potentially catastrophic consequences? Despite the allure of time travel, these paradoxes suggest a universe that resists such manipulation. Perhaps they serve as a warning or a protective mechanism to prevent us from tampering with the delicate fabric of time. Maybe it's best to leave time travel to the movies. What if your watch could run slower just by climbing a mountain? Sounds absurd, right? But stick with me here because this is where things get really interesting. Picture this. You're standing at the foot of a majestic mountain, your trusty wristwatch securely fastened, ticking away as usual. You begin your ascent. As you climb higher, something peculiar happens. You may not notice it, but according to Einstein's theory of relativity, your watch is ticking ever so slightly slower than it was at the base of the mountain. Why, you ask? It all comes down to gravity. You see, gravity isn't just the force that keeps your feet on the ground. It's also a curve in space-time. An invisible dent in the fabric of the universe. This dent is deeper where gravity is stronger, like at sea level, and shallower where gravity is weaker, like at the top of a mountain. Now here's the kicker. Time runs slower where gravity is stronger. This is a key part of Einstein's theory of general relativity, which tells us that gravity isn't just a force pulling objects together, it's a warping of space and time. The difference in the pace of time isn't much. We're talking fractions of a second over a lifetime, but it's measurable. In fact, scientists have tested this by comparing atomic clocks at different altitudes. And every time, the clock at a higher altitude runs faster. But don't get too excited about this as a method to slow down aging. The difference is so minuscule that you wouldn't notice it in a human lifespan. And besides, there are much easier ways to slow down time in a metaphorical sense, like taking the time to appreciate the world around us, savoring moments and creating memories. It's astounding, isn't it? The universe we live in is full of such mind-boggling phenomena where even the concept of time isn't as straightforward as it seems. So if you ever want to slow down time, just go for a hike. And while you're at it, take a moment to marvel at the intricate dance of space, time, and gravity. The universe certainly has a quirky sense of time. We've journeyed through the cosmos, exploring the fascinating concept of time dilation. We've delved into the fabric of space-time, understanding how mass and gravity distort time in ways that boggle the mind. We've ventured to other planets where time takes on a whole new meaning. Martian days are longer than ours on Earth, while on Jupiter, they're shorter. It's a cosmic dance of time that's as diverse as the universe itself. We even dared to dream about time travel, navigating the paradoxes and possibilities that come with it. And through it all, we've come to understand one fundamental truth: the relativity of time. Time is not a fixed entity. It's elastic, bending and stretching in response to the universe's forces. This is the beauty of time, and the mystery that keeps us reaching for the stars. Remember, time is relative, so make the most of yours.